CNC Spindles explained, how to choose the right power for your CNC router and why it matters. When people buy a CNC router, they usually compare the working area, the number of axes, or whether the machine includes an automatic tool changer. While all of those features are important, there is one component that determines how well the machine actually performs. That component is the spindle. The spindle is often called the heart of every CNC router because it is responsible for spinning the cutting tool at high speed and removing material with precision. The quality, power, and design of the spindle directly affect machining speed, cutting quality, tool life, noise levels, and overall productivity. Choosing the wrong spindle can lead to vibration, poor surface finish, excessive tool wear, and lower production efficiency. In this video, we'll explain everything you need to know about CNC spindles, including how they work, how much power you really need, and how to choose the right spindle for your workshop. What is a CNC spindle? A CNC spindle is a high-speed electric motor specifically designed to rotate cutting tools. Unlike conventional electric motors, CNC spindles are engineered for continuous operation at very high rotational speeds. Depending on the model, spindle speeds typically range from 6,000 to 24,000 revolutions per minute, while some specialized spindles exceed 30,000 RPM. Their primary purpose is to provide stable, vibration-free rotation while delivering enough power to machine wood, MDF, plywood, plastics, aluminum, and composite materials. Without the spindle, a CNC router simply cannot perform any cutting operation. How does a CNC spindle work? The spindle itself is controlled by a variable frequency drive, commonly known as a VFD. The VFD converts electrical power into precisely controlled frequency and voltage, allowing the spindle speed to be adjusted for different materials and cutting tools. Hardwood, MDF, plywood, plastics, and aluminum all require different spindle speeds. By selecting the correct RPM, the machine produces cleaner cuts, longer tool life, and better overall machining quality. The spindle, cutting tool, and VFD work together as one integrated system. Why is the spindle so important? Many people assume spindle power only affects cutting speed. In reality, it influences almost every aspect of machining. A high-quality spindle improves dimensional accuracy, reduces vibration, creates smoother surface finishes, extends tool life, lowers machine noise, and allows higher feed rates. For professional production, spindle quality often has a greater impact than many people realize. Understanding spindle power. Spindle power is measured in kilowatts. The higher the power rating, the more cutting force the spindle can deliver. However, bigger isn't always better. The ideal spindle depends on the type of work you perform. A small engraving workshop has very different requirements than a furniture factory operating multiple shifts every day. Choosing the correct power means balancing performance, energy consumption, and investment cost. Common spindle power ratings. Small 1.5 kilowatt spindles are commonly used for engraving, hobby projects, and light-duty machining. The popular 2.2 kilowatt spindle is an excellent choice for MDF, plywood, particle board, and general woodworking. Professional workshops often choose spindles between 3.5 and 4.5 kilowatts because they provide faster feed rates and support larger cutting tools. 6 kilowatt spindles have become the industry standard for furniture production, especially on CNC routers equipped with automatic tool changers. Large industrial machines may use 9 or even 12 kilowatt spindles for demanding production environments. Air-cooled versus water-cooled spindles. One of the most common questions concerns cooling. Air-cooled spindles are mechanically simple and require very little maintenance. Because they use built-in cooling fans, installation is straightforward. Water-cooled spindles operate much more quietly and maintain a more stable operating temperature. For continuous industrial production, water cooling generally provides better long-term performance. Each system has advantages, and the best choice depends on your workload and production environment. Tool holders. The spindle itself is only one part of the system. The cutting tool is secured using a precision tool holder. Common collet systems include ER20, ER25, and ER32. Professional ATC machines frequently use ISO 30 or HSK tool holders because they allow extremely fast and accurate automatic tool changes. High-quality tool holders are essential for minimizing vibration and maximizing machining accuracy. Choosing the right spindle. The perfect spindle depends on several factors. What materials will you machine? How many hours per day will the machine operate? Do you need an automatic tool changer? Will you perform heavy cutting or fine engraving? How important are noise levels? Answering these questions will help you choose the spindle that best matches your production requirements. Common mistakes. Many first-time buyers make expensive mistakes. Some purchase the cheapest spindle available. Others buy far more power than they actually need. Some ignore bearing quality or cooling requirements. Using poor quality tool holders or unbalanced cutting tools can also reduce spindle life dramatically. Selecting a quality spindle from a reputable manufacturer is usually a much better long-term investment than simply choosing the lowest price. Final thoughts. The spindle is far more than just another motor. It is the component that transforms digital designs into finished products. Whether you're engraving decorative panels, manufacturing kitchen cabinets, or producing custom furniture, spindle performance directly influences your results. By choosing the right spindle power, using quality cutting tools, and maintaining the spindle correctly, you'll achieve better surface finishes, faster production, and longer machine life. For most professional woodworking businesses, a 6 kilowatt water-cooled spindle with an automatic tool changer provides an excellent balance between power, precision, and productivity. A well-chosen spindle isn't simply an expense. It's an investment that pays for itself through higher quality, greater efficiency, and long-term reliability.